Okay, look at the camera. Say hi.
Hi.
So for Valentine's Day, my wife asked me to make her this pinwheel, or whirligig. I think it's a pinwheel. I think that's a technical term for it. And once I made this project, I fell in love with it. This, I think, is the best thing that I've ever 3D printed. It's so cool. Viscerally, the materiality of it, the translucent orange and the color gradient change filament, it looks so neat, you guys. So, total winner, best thing I've ever made on my 3D printers, I think. And what do you think of it, Dax?
I think it's good.
You think it's good? Do you like that one, or do you like this one?
I like this one.
You like the green one, yeah. So this is the wife's. That one's yours, and then this is the best version of it that I've made. The color gradient change is just so clean. You see that, guys? So yeah, lots of lessons were learned making this project. I think it was about the most informative, instructive project.
Did you see that, Dada? I did this.
Whoa! Hold down low here. And then here, I'll blow on it. Ready?
Watch when I do.
Anyway, yeah, lots of lessons learned. I'm going to share them with you. Let's get into it. I got this roll of color change rainbow PETG filament, and I've been waiting for the perfect project to use it with, and this turned out to be the perfect one. But you can see that the color change doesn't happen quickly. So I needed to print actually this is just 4 of them, but I needed to print 4 copies of the project to get a good gradient change on the parts. And I have no choice in the color. It's wherever the roll happens to be. So if I'm going to do another version of these, the hubs are going to start out as an orange color. That's just the way that goes. So lesson learned with this color change filament, it's kind of a hack. It can produce an interesting result, but it's really not very controllable, and you're at the mercy of the filament. See, look at this hub here. This was printed as a single hub, and you can hardly see the color change gradient happening at all. The green piece here was, there were a couple of mistakes, so I burned through some more of the green filament, and it had changed color by the time I got there. So there's another lesson learned. The parts aren't going to match unless you print them like this. So if you're going to make a multi-part assembly with color change, you have to print it all in one go if you want the parts to look like they belong together. But yeah, I'm having great results with that filament. I'll put a link in the description to where I got that. As far as the blades go, the Delta printer here seemed like the absolute perfect printer for the job, because the bed doesn't move, and I didn't want inertia causing this thing to sort of flex as it was printing. So the blade stays perfectly stationary, and it's just the head of the printer that moves around. Also, I've told you guys before, I'll say it again, Delta printers are not the most accurate for engineered components, which this is gonna slide into and engage with the hubs there. It's okay though. It's very small, this part here, and like I've said, the closer to the center of the bed that you're printing, the more accurate your Delta printer is going to be. So this did turn out to be the perfect printer for this part, but it's got its problems. Delta printers are supposed to be fantastic for speed, and this one is a very fast printer. The problem is I can't use it at its full speed potential because I'm printing with PETG. So PETG, the filament itself dictates how fast you can print, and I'm finding 50 millimeters per second is about as fast as I want to go. That's real time, you guys, and that's as fast as I've been successfully able to make these parts on this Delta, which is capable of moving like 4 times this speed. I'm printing these with a single wall. That's a vase mode spiralized single wall, and it's got 120% extrusion, so that I'm getting really, really good just mashing those layers together, and it does make for very strong parts. If I squeeze it, it feels kind of like a Nike Air. It does have some microscopic pores, so if I squeeze that for the long time, it will leak down, but yeah, not really. Very, very minimal air leakage there. So if I leave this outdoors, I'm less worried about ingress of moisture and bacteria and algae and whatnot growing inside of the wing. By the way, you guys remember a couple of videos ago when I was talking about this nozzle cleaning brush and the attempt to make one with silicone wiper blades. Well, here I am doing this project with tons of retractions and gaps between the parts, and you can see zero stringing, absolutely no issues. So I don't always have that problem. The key, like I said, is to use dry filament. So you absolutely need to have a filament dryer to achieve results like this, unless you're opening a fresh, brand new filament. But the thing is, these filaments rolls can get soaked up moisture in them, even being stored at the Amazon warehouse or wherever they come from. If they made this thing 3 years ago and it's been sitting on a shelf, even the plastic bag with the desiccant in it doesn't prevent the moisture from getting into the filament. So you absolutely need a filament dryer if you want to have consistent results like this. But I still recommend that brush. It's a nice safety feature. Unfortunately, I can't fit one of the brushes on this printer. They're just there isn't the overrunning travel outside of this bed. And the same goes, of course, for my Delta printer here. That nozzle really can only make it onto the bed. So it'd be hard to implement a brush functionality. Of course, it could be done. I could put something up high like here and have the between every layer, the nozzle lifts way up, wipes, and goes back down into printing. But what a pain in the butt that would be. So yeah, like I showed in the intro, the finished version is just so spectacular. It doesn't have that monolithic color to it, so it makes it seem more exotic and less cheap just because it's got that gradient color change. Yeah, it's just so cool. And the translucent wings, right? They certainly help with the aesthetics of it. I can't explain it. It's just I mean, I was making this thing, and as I was designing it, I have full understanding over every single element that went into this, and yet the final result is it's just so cool. So yeah, this is the final version, and I made 4 copies of it to give to friends and family because, you have a winner of a project when people that see it want it. They ask you for it. So most of my projects just end up, for me, sitting here in my office with me, and people don't really see the value of them except for maybe some of you guys on my YouTube channel. But yeah, this is definitely a valuable thing. I love it. So let's talk about how this final product was reached. I started off with this design. This is my first iteration, and everything about this, literally every single thing about this, is different from the final version except for one single surface. There's a semicircle here, and of course it's mirrored on the other side. And that semicircle was trimmed to make these pointy bits here, but there is a portion of that semicircle still intact, and that is the only similarity between these two designs. So with this design, the idea was to retain the bearing using this plug at the front, and this was kind of fun to draw. I got to, create some threads, offset them, and so the threading works, and you can see the bearing down in there. It's actually a pressed fit, so I suppose over time it could work its way out, and this just presses against the outer race of the bearing, and of course the bolt holds the inner race. And yeah, this works quite well. Now, functional as this design is, it's pretty fiddly to get that. Oh, look, it went together just fine that time. But it can be really fiddly to get that plug threaded in there. Of course, I could alleviate that problem with a chamfer if I was going to continue with this design, but I didn't. There's lots of things that are not optimal. The blades here are held in place with these pieces of filament. They're just pins, basically. And I melted them flush with a soldering iron, which also sort of like cements them in place. The large flat cross section here was problematic for 2 reasons. First of all, this is kind of skinny and that's kind of wide. So as I was printing, way up here, the slight drag forces of the nozzle printing across this blade was flexing the blade during the print, but only in this direction where there's a skinny cross section. And that's why the final design here has much wider profile in that direction and narrower in this direction. Narrower also because this sort of paddle, this flap wheel, resisting the spinning forces is not ideal when this is being driven by the wind. So you have forces here which hit the 45 and cause it to spin, and then this is resisting it. So you're going to get a slower spin with this one than with this one. It's just the blade is more efficient here. Now, for printability, I had to make the top of this open. You can see that. The problem I was having is I couldn't get good, call it bridging. the sealing on the inside was failing on me, and then there were lots of holes, gaps in the print. And normally with a print that's not with this translucent material, what I would do is start some infill material, maybe around where my fingernail is here. And so you have like 2 or 3 layers of infill, and then that sealing has a support network underneath it, which, you know, causes the outside of the print, by the time it gets to the outside layers, it's flawless and it looks gorgeous. But with this, you know, being able to see through it all the way, you'd be able to see those features, and it really kind of destroys the aesthetics of it. So the best technique I came to was to just leave it open for this the rounded wing shape. But that's why I went with the pointed wing here, because this is the magical 45-degree angle, and you get flawless prints all the way to the tippy top. So yeah, this makes a enclosed thing, and like I said, it's kind of pressurized. If I squeeze it, it feels like a balloon, or, you know, like a pressurized thing, very much like a Nike Air, like I said. The microscopic holes are at the very tips, so even with this 45-degree, I still have the problems right there. But yeah, so if I squeeze this and hold the pressure on it, it slowly deflates, and then it's just kind of, you can see the convexness to it. So that'll reinflate itself here in a minute or so. Now this was the second iteration, and you can see some small changes between this one and this one. See how the top works there versus the top over here, and yeah, there were some other small tweaks, just dialing it in, getting the bearing mount correct, it was mostly this part that changed, but yeah. So iteration number 2 also figured out about the gradient change filament, how I needed to be extruding more filament, which means I needed to print multiple parts together in order to burn through the filament more quickly and get that gradient to work. But I don't generally like to do multiple parts on a single print, and the reason for that is that you have a higher likelihood of failure. So you can have layer skips or that kind of a thing happen while you're shifting between parts, while you know there's a travel move in between them. And if you do have a failure and your print gets ruined, you've lost 4 parts instead of just 1, whereas if you have a failure with a single part. So because I'm always prototyping and I never have a chance to really dial in my prints just for, reliability and the highest quality, everything's always changing. It's always in flux. So yeah, the multiple parts nested together in a single print is ideal for a production environment, but usually not ideal for me. But in this case, obviously I had to do it to get the color change. The other way to do a color change would be with like a mixing nozzle, maybe even like a diamond hot end, but then you got to get really fancy with your slicer and your firmware in order to tell the green stepper motor to extrude more than the orange stepper motor. So if you had 2 filament colors going in and you would want to change, you would want to gradually change from green to orange, there would be sort of a dial effect, and that would be quite tricky to get that to work, but it's definitely possible. So if I was mass producing these things, that would absolutely be the problem to be solved there. So it's not the easiest thing to figure out how to mass produce these, but I was able to get a great result with that color change filament. Back to the challenges of printing these single wall blades. Let's look at some of these failed prints here because they're really instructive. This is what it looks like when I try to print too quickly. You can see doing okay around here, and then once it starts to kind of break loose, it's usually during direction change, and you can see the filament basically doesn't have time to heat up the layer beneath it. So that doesn't get good bonding between the layers. And then when that molten filament tries to change directions quickly, the filament tries to shrink a little bit, find the straightest possible path. And because it's not fully bonded to the layer below it, this kind of crap happens where it breaks loose and you just stop getting good adhesion. So I had to slow down my print in order to avoid this. But even slowing down my print, I still had issues, more or less the same issue. You can see it here on this part where, yeah, you see it right there. So it's much smaller, but it's the same effect. And that was because you can see the radius decreased. So I tried to get a much thinner blade here. And with that gap, there's still a gap there, that narrow radius for that gap, I literally could not figure out a solution to get that clean print. So that's why I modified the geometry to look like this, where the radius never gets smaller than that. That was the smallest radius I could find that effectively worked. So yeah, the design of this thing was a feedback loop. It was largely informed by the printability of it. So it wasn't just aesthetics that made this happen. It was can it be made? Now you can see that this issue is still persistent way up here. And what's happening is by the time I get to right there, now I'm printing, basically these are married together. They're so close, they might as well be merged. And so if I can get to a point where it's just two walls thick and they're touching, then I don't have this issue. But there's always going to be that transition from this fat radius to this little skinny radius. And so I just abandoned this really thin blade technique. This is not the design that I went with for printability. Here you can see more of that same issue, also on a very thin blade, and I think I slowed it down. I think this is a combination of bad geometry and trying to print too quickly. And this one shows the difficulty I was having with that through hole. Now these down here at the bottom, you can see they're darker, and that means that I've got a double wall for strength, just because that's getting gripped in the hub. And the same technique was used on these pointy wings. That's doubled up down there at the bottom. The single vase mode doesn't start until right there. So yeah, that through hole was more of a challenge, took longer to print. It was better to sort of dovetail the base of this one. And let's jump on the computer and I'll show you that dovetail in detail. Just to give you guys a quick glimpse into my design process, I started all of these iterations with the blade. So the very first blade design that I came up with was this. And usually your first design is not the best, but I think this, as I was working through it, this was what I came up with. And I do like it. It's very aesthetic and it's very simple. And, you know, as Mies van der Rohe said, less is more. So simplicity, aesthetic simplicity really is appealing. Anyway, after I had that blade, what I did is I arrayed it 7 times around this hub. So this was, I was going to make like a sort of a cone over the top of this hub, kind of look like an airplane propeller hub. And I went with 7 blades because that's just the paradigm, right? Prime numbers of blades, 7, 11, 5. These blade numbers tend to, you don't get the periodization, right? Because they're prime. So finding multiples, you don't get those waves, those sound waves. So you want multiple blades to really eliminate the noise coming off of your fans. And this is a technique widely used in, like, you know, air conditioning fans or computer case fans, all this kind of a thing. And so that was my starting point. I thought, you know, that's the way it's done. So that's the way I did it. But pretty quickly I realized that this is just really cluttered looking and it's a whole lot of printing. And I'd like to print these things more rapidly and I don't need all of those blades. So I decided to go with a 3-bladed design. Didn't really like that. And when I decided to try out a 4-blade design, I actually twisted the blades like this. And in fact, those are laid out 60 degrees apart from each other. So it's effectively a 6-sided blade that I've deleted 2 of the blades to make it a 4-bladed fan. The hub here. So you can see this was kind of the base hub. I didn't save all of the iterations, all the previous versions of it, just that. But then I made these threads and those were quite involved. You can see down here, this is the cross section to those threads. And there's a command called helix. And you can see it draws a spiral, which I can then sort of flow those cross-section curves along that spiral once I've drawn that. So it's a very manual and sort of cognitively intense way of drawing threads. But if you want custom threads where every bit of it is custom or chunky, that's the way to do it. I think a thread wizard would tend to make like standard thread pitches that you would see in nuts and bolts and whatnot. So sometimes I've made threads that are hemispheres, or semicircles, I should say. So there's all kinds of neat things that you can do when you can really make your own thread pitches. There was a project with my Shaper Origin where the vacuum cleaner hose is actually a spiral hose. It's a flexible hose. And I was able to match that spiral, ribbing and thread a piece onto it. So yeah, being able to draw custom threads is a good skill to have. Okay, so the next thing was to make this blade here. And this is the blade that we were talking about, in the physical version of it a minute ago. You can see what I've got is this mushrooming out at the bottom, this dovetailed shape. It's this shape right here. And that is constrained on all sides by a corresponding, cavity for the fan blade to sit inside of. So I didn't need the through pin. I can just attach the hub around it, and it's not going to go anywhere. So again, starting this this whole design off with the blade design, and then moving on from there. This is where I went to next. Very simple, basic hub design. Anybody can come up with this geometry here in almost any CAD program, but Rhino, which is the program that I use, is actually incredibly capable of surfacing. Here we can see this thing that I made, and this is a cluster, man. This is terrible. This is terrible. But let me just run a zebra command on this. And what you can see is this is basically turning into sort of a reflective chrome object with, like, what if you had a piece of cardboard here with black and white lines, like zebra stripes on it, and you were reflecting the zebras off of this chrome object. That's what you get here. And you can see, like, right there in the middle between the two halves, there's kind of a crease. You see how there's kind of a sharp point there? There, you can see it right there, that jaggedness to it. That's a crease. That's not a planar, or not planar. It's not a tangent continuous gap or seam between those two surfaces. So that would be a surface that I have to work on. So I can do what's called like match surface. And you can see that that zigzag has gone away. Unfortunately, now we got this new problem happening here. We have a gap because as I matched those surfaces, in order for the program to pull those surfaces into being tangent to one another, it affected the other edge. So it is quite a battle, and being expert at surfacing is like an employable skill. So if you can get your Rhino skills to this level, there are jobs for you for sure. It's intense. With a rendered view, we can see just kind of what it's going to look like. We can see that little crease right there at the top, and we can see all these dimples in funny places. And yeah, it's tangent, and the shininess of it doesn't look too bad. Like, you know, it looks okay, but it just, no, it's not good. So I pretty much made this version out of stubbornness. It's been more than a year since, like in a professional capacity, I needed to do some surfacing work, and I really just wanted to kind of brush up on my skills and remember a lot of the commands that I just hardly ever use. Thankfully, I now have Rhino 7. That's what you see here, Rhino 7. And Rhino 7 comes with an amazing functionality, and that is called Subdivision Surface Modeling. And Sub-D meshes are amazing. So look at this very beautiful version. And this, I think if you've ever used Blender, you will find this to be familiar. But watch this. I can basically come in here, and let's just grab this one. Sure, just for the heck of it, let's grab this corner, and then I'll lift it straight up into the air. So I can just sort of morph it and blend it in any way that I see fit. And I can do it symmetrically, or I can do, you know, individual, you know, that's going to be too far. That's going to lead to problems. But, you know, it's going to be tangent smooth. There are no creases. It's perfectly blended everywhere. Of course, this type of modeling also has its drawbacks, and there's a place and a time for surfacing work in Rhino, and then there's a place to use the sub-D modeling. And anyway, after you're done with sub-D modeling, you can basically export the sub-D into a NURBS, which is the general Rhino surfacing. So it converts between the two. So now we're back to NURBS, which allows me to do all of the angular engineered surfaces that I would normally do, just, you know, to get things to work. So there you go. That is the final product right there. So it started out sub-D, and then I basically put all of the engineered facets into it, such as the holes and the hub, or sorry, the blade retaining cutouts, the dovetail cutouts. Now I want to make a point about Cad software, because everything I've showed you guys is kind of an interesting curiosity for the vast majority of you, because most of you are using Fusion 360, and you guys got started with Fusion 360 because it's free, right? Or it was free. Autodesk will charge you in the end. That's what they do, right? Did you guys know that the first versions of AutoCAD that were free were the pirated versions, right? On Napster even. And they didn't offer free student licenses or anything like that. Their free version was literally the pirated version, and it was released by AutoCAD. Like this has been revealed. AutoCAD themselves put their pirated copy out there, and they hook you, they get you. And once you're hooked on their software, they start charging you more and more. So they're going to keep on ratcheting up that price for Fusion 360, but you will have spent thousands of hours of your life getting good at Fusion 360, and you will be reluctant to change softwares. Or you'll watch some YouTuber talking about an alternative CAD platform, and you will just like decide that you hate his CAD platform and you love yours just because you're good at it, right? It takes so many hours to get good at these softwares that it's understandable. The cognitive burden to learn a new software is quite high. So Fusion 360, along with SolidWorks and CATIA and Onshape and Siemens NX and all of these programs look very similar and they function very similarly. And they are called parametric modelers. But listen, Rhino's a parametric modeler as well in an entirely different way. We have the Grasshopper plugin, and you can make your drawings parameter driven, so much so that you can actually write Python scripts to generate geometry automatically with Rhino. It's called Iron Python. It's phenomenal. It's what I did my thesis with, right? You can go down the rabbit hole as deep as you want to make Rhino parameter driven, but this parametric functionality is just a sort of a sales tactic of these engineering CAD platforms. So if you are a professional engineer who's going to be working with other professional engineers, or doing things like bending the metal on a brake, and so you need to use the plugin, the press brake, calculating plugin. So all you have to do is draw the geometry, and then the engineering program automatically generates the cut file with the offsets for the bends, that kind of a thing, right? Then these professional engineering CAD platforms are ideal. Those are ideal. But for the vast majority of people who are seeing my videos, you, like me, are a designer or a singular engineer. And in my experience, you would be far better off using Rhino. I absolutely love this CAD platform, and it's very popular in architecture programs, which is obviously why I learned it. I've got a master's degree in architecture, right? So that's where I was exposed to this software and really fell in love with it. But on the internet, you don't see a whole lot of presence for this software package. And that's kind of a tragedy, because I do think that most of you would be better served to be learning Rhino than Fusion 360. Of course, you have to pay for Rhino, so that's a subject, another subject. It's reasonably priced, but I'm not going to talk about that now. Anyway, you can see just how much phenomenal functionality there is in this CAD software. And here's a look at the two fan designs in Rhino. We've already seen them in reality, but I can do a rendered view, which is just kind of a quick and dirty to get an idea of what they're going to look like, or I can do a ray traced rendered view here, which is going to kind of go through. Well, if you're into gaming, you know about ray tracing, and it's resource intensive on your computer, but it makes phenomenal results. And this was just a quick material application. I spent all of 2 minutes assigning a couple of materials to this. You can see in my materials library right there. So all built into Rhino, really nice. And it gives me a great idea of what the final product is going to look like. So I love this CAD platform. I have 3D printed a lot of things, a lot of different designs. And this one is the most impressive. It's functional art. Like, so much of the time you guys see me making parts for 3D printers, which are more towards the engineering side of things. They're going to be shaped the way that they are to serve a function. And I definitely lean towards the function side in the function versus form debate. But in this case, it's fully functional. I guess the function is pretty basic. It just has to spin when the wind hits it. But the form is just so gorgeous because of that color change gradient filament. So if I was running a 3D printer farm and I was trying to sell objects, I think this would be a really good candidate for the product that I would try to launch. Now, given my experience in manufacturing, I have a patent on the buckle and all that, and I still have inventory for those bags, and it's hard to get those to move, especially now during the pandemic when nobody can travel because they are a travel bag. But it's been my experience that at least for my skill set, the hard part is not making it or getting it made or even coming in at a certain dollar. All of those things which seem to be challenges. The problem is always sales. Getting eyeballs on your product and getting people to buy it is the challenge. So yeah, I mean, I know how to make this. It's awesome looking. I do think that there is an appeal to it, but getting it out there would be hard. So what are you going to do? Get it into Walmart, maybe? That would be pretty cool. But then you wouldn't be able to 3D print it because you would not be able to meet the scale, the number of units that Walmart would want to sell. So this design could be adapted to being injection molded. I would use some blow molding. It's a different production technique. I would use blow molding for the fan blades. But then it would be a different product. So as far as running a print farm and selling small quantities of this go, I think this would be the best design of mine to try to do that with. But you know, hey, I've got videos to make, I've got a motorhome to build and all that. So I won't be making this into a print farm project anytime too soon, viable as it might be. So I love it. I think it's the best thing I've ever made just because it is visually so appealing. And you know, it's fun. It is fun. It's funny how the stupidest things, it just spins, but it spins in the wind. And whirligigs or pinwheels, they're awesome. So yeah, it's a thing. I love it. That'll do it for this one. Thanks for watching. See you next time.
Are you done?
I'm all done.
Now can I make loud noises?
Yes, now you can make loud noises.
Thank you!
Woohoo! A big thank you to these Patreon supporters. You guys keep the channel going. Thank you so much.